Hey guys, it's Miss Miklos, and in today's lecture, we're starting the polar portion of Chapter 9. And today we're going to really focus on the basics, which is just dealing with polar coordinates and understanding what those actually mean. So, in order to do that, we're going to go back in time here and talk about the unit circle. So, remembering the unit circle, okay, we worked with radians. And we also worked with degrees. So with radians, I just want to remind us that each line is equal to pi over 12. So we know pi, once again, means a semicircle. So 1/12 of a semicircle is each line. Okay, and today we're going to be graphing on polar graphs. Degrees, which I know we normally feel more confident with, each line is equal to 15 degrees. Okay, so it's important for us to remember that each one is 15. Okay, the only thing that's wrong with this is they should all have little degree symbols. Each radian is pi over 12. And I just want to remind us once again, pi is equal to a semicircle. So that's stuff we've previously learned, but as we know, things that we've learned in the past often come up again and again, so I just want to remind us. The rectangular coordinate plane is what we're very used to dealing with. And in the rectangular coordinate, the ordered pairs are always x, y. Okay, so we're used to moving right and left, whatever the x amount is, moving up and down, whatever the y amount is. Today, we're talking about polar coordinates. And in polar coordinates, our ordered pairs are r, theta. So I just want to talk about what r means first. R is the radius, which really means the length. How far out are we going? And we know theta is specifically telling us an angle. So instead of x and y, we're dealing with r and theta. And the way that we're going to actually graph here is we are always going to start with r. Okay, with the r. If r is positive, we are going to move to the right. And if r is negative, we are going to move to the left. Which that makes sense to us that positive values we would move to the right, negative values we would move left, because that's what we do with our x. Then, once I move in the appropriate manner, we need to move to the appropriate angle. Okay, and just a reminder, if it's positive, we need to move counterclockwise. And if it is a negative angle, we need to move clockwise. And this is all stuff we've done in Algebra 2, and even in this year, just dealing with angles and the way that they move. But we haven't seen it in a few chapters, so it's a good reminder for us. So, the very first thing that we're going to go ahead and do here is just plot ordered pairs on a graph. And I promise you guys, we will have a quiz next time when I see you guys on this concept. So we need to know, how do we graph ordered pairs? So for this example, we have a giant graph here, and we have a bunch of ordered pairs. The first thing I want to do here, I just want to make it really, really obvious what our quadrantals are. Okay, so hopefully that just makes it a little bit easier for us when we're actually graphing. Okay, so back up to the problems. So it says graph the following ordered pairs and label them on the graph. So if we look at A, 3 pi over 6. So I'm going to go ahead and write underneath what this is actually meaning for us to do. I know that our R value is telling us how far to go. Since it's positive, it's telling me to move to the right 3. So I'm going to use RT as an abbreviation for right. And we need to move pi over 6. Now, some of you guys are great in radians. Just a reminder, if I'm not as good in radians, I can always convert it into degrees by multiplying by 180 over pi. So if I do pi over 6 times 180 over pi, I get 30 degrees. So this is telling me to move counterclockwise 30 degrees. Okay, counterclockwise is because this is a positive angle. So I'm going to move down here. I'm going to zoom back out a little bit here. There we go. So I'm going to start by going to the right. 1, 2, 3. Now I need to move counterclockwise 30 degrees. We know each line is worth 15, so that'd be 15. This would be 30. So I'm going to go ahead and put my point right here and label it A. Okay, so once again, I went out 1, 2, 3, and up 15, 30 degrees. Now the next one, okay, what makes this one a little bit different for B is that my R value this time is negative. So this is telling me that I need to move to the left 2. And then if I multiplied by 180 degrees over pi, I end up getting that this is equivalent to 330 degrees. And once again, I'm moving counterclockwise 330 degrees. So back here, I'm going to the left 1, 2. Now counterclockwise would be this way, so that would be 180, 270, 300, 330. So I'm going to go ahead, and I totally lost track of where I was. I think I was right there. So I'm going to go ahead and label that point B. So just to review what we did there, we moved 2 to the left, and then from this point, notice this isn't 330 degrees. I had to move 330 degrees from here. So I went 180, 270, 300, 330. Now another way we could have thought about this, 330 is the same as negative 30 degrees. So I could have moved negative 30 degrees and moved in the clockwise manner. So there's a lot of different ways we could go about thinking about these problems. Okay, for C, C is telling us that we are going to move to the right 4. And when I convert that into degrees, I get 135 degrees. So I'm going to start going to the right. 1, 2, 3, 4. And I'm going to go 90, 120, 135. So point C would be up here. So as you guys are seeing, this is just a lot of practice. The more I practice this, the better I get at it. And in order to graph anything, before we can actually graph equations, we need to know how to graph ordered pairs. Before you guys started graphing anything in the rectangular coordinate, we learned how to graph ordered pairs of x and y. So if we look at D, this is telling me to go to the right 5. And this time my angle is negative. So it's telling me to go clockwise 90 degrees because I know pi over 2 is equivalent to 90. So I am starting going to the right 1, 2, 3, 4, 5, and I'm going to go clockwise 90 degrees. So my point is going to be down here, and that would be point D. Okay, E is telling me to go to the right 5 and go counterclockwise 60 degrees. I definitely did not mean to draw that right in the middle of everything. There we go. Okay, so counterclockwise 60 degrees to the right 5. So I'm going to go to the right. 1, 2, 3, 4, 5, 30, 60 degrees. So that would be point E. Next, I'm going to go to the left 5, and when I convert this into degrees, I end up getting that we're going to move counterclockwise 240 degrees. So I'm moving to the left, 1, 2, 3, 4, 5, and I'm moving counterclockwise 240. So I'm going to go 180, 210, 240. Now notice we already put a point there, and that's okay. Okay, I'm also going to label this point F. And this is just going to show that in a polar graph, we can have two different names for the same ordered pair. Okay, for G, this is telling me to go to the right 6, and then clockwise, when I multiply by 180 over pi, I get 135 degrees. So I'm going to go to the right, 1, 2, 3, 4, 5, 6, and then I'm going to go clockwise, 90, 120, 135. And that was point G. 3, 15 degrees. This one should be nice and easy for us. I'm moving to the right 3, and then I'm going clockwise 15 degrees. So I'm going to the right 1, 2, 3, and I don't know why I said clockwise. It should be counterclockwise, shouldn't it? Because this is a positive angle. Okay, back on track. I went to the right 1, 2, 3, and I'm going clockwise. So this is my ordered pair, and that would be H. Hopefully this is boring to you guys because we're understanding it so well. But just to make sure, we're going to do the last two. Okay, this one I'm going to the left 3, and I'm going clockwise 15 degrees. So I'm going to the left 1, 2, 3, and clockwise 15 degrees, which puts me right here, which would be point I. And lastly, this is telling me to move 0, 90 degrees. Now, if I'm not moving anywhere, regardless of what the angle is, my answer is going to be at the origin. Okay, so this is just a little glimpse at what these ordered pairs look like. This is just something we need to practice. The more you practice it, the easier it gets, the better it becomes. So now that we've seen how to plot polar ordered pairs, we're going to go ahead and actually learn how do we convert them from the rectangular coordinates into polar and vice versa. So in order to establish the relationship between polar and rectangular coordinates, we're going to let the polar axis coincide with the positive x-axis and the pole with the origin as shown in this figure over here. Because xy lies on a radius r, it follows that r squared is equal to x squared plus y squared, because this would be the Pythagorean theorem. Moreover, we can also use our trig functions to help us out. So tan of theta is opposite over adjacent, cosine would be adjacent over hypotenuse, and sine would be opposite over hypotenuse. So if we look at the coordinate conversion, okay, these are 4 things you guys need to absolutely have memorized. To convert from polar to rectangular, so if I want it to be x or y, we use x equals r cosine theta. The reason being, okay, we're using this trig function, this trig ratio, and if I multiplied both sides by r, I get x equals r cosine theta. So it all comes from this right triangle right here. Now I know some of you guys could care less where it comes from. You just want to know, what do I need to memorize? So here you go. That's what you need to memorize. For those of you that care, our other one, y equals r sine theta, comes from our ratio of using the opposite over the hypotenuse. So in this case, we took this sine ratio and multiplied both sides by r. So x and cosine are together, and y, and I know you guys know what's coming, y sine, I don't know. So they kind of go together. So that's how we change things into terms of x and y. Now for rectangular to polar, we're going to use tan of theta equals y over x. If I know the y and the x values, I can make this ratio and do tan inverse of this value, and it will tell me what our angle is. To find the radius, we can use Pythagorean theorem and do r squared equals x squared plus y squared. So before we get into this, there's a few notes that we need to remember. First of all, our calculator should be in terms of radians. Okay, so that's a good thing to double check with your mode. I also just want to review some material that we've previously learned with sine, cosine, and tangent. And I want to just kind of focus on our three major angles, pi over 3, pi over 4, and pi over 6. Okay, pi over 3 we know is the same thing as 60 degrees. Our sine value is radical 3 over 2. Our cosine is 1/2, and our tangent is radical 3. Pi over 4 is like 45 degrees, so our sine is radical 2 over 2. Our cosine is radical 2 over 2, and our tangent is 1. Pi over 6 is equivalent to 30 degrees, and our sine value is 1/2. My cosine value is radical 3 over 2, and our tangent is radical 3 over 3. So these are things that we've learned previously, and I want to stress we still need to know these. These do not go away. We need to have those values memorized. So we're going to start with just converting points. So we have a polar point here, and we want it to be in rectangular coordinates. So I'm going to find x first. We know x is equal to r cosine theta. So x equals r is 2 cosine of pi. Now, there's two ways that we can find cosine of pi. We may remember that we can put that into our calculator technically and find it. The other thing I just want to remind us of, we learned that sine is the y value, cosine is the x value, and tangent is y over x. Okay, and our ordered pairs for quadrantals, this would be 1, 0. Okay, and that would be 0 or 2 pi. Pi over 2 would be an ordered pair of 0, 1. I know you guys are excited to have to remember all this. Pi is like -1, 0. And 3 pi over 2 is like 0, -1. Okay, so this is stuff we still need to remember. So if I'm doing cosine of pi, okay, our pi ordered pair is -1, 0. Cosine is our x value, which is -1. So I'm going to go ahead and say x equals 2 times -1. So our x value is equal to -2. Now we also need to find the y value. So the y value is equal to r sine theta. It's a lovely S I drew, and I don't know why I'm writing r again. There we go. So we said our r is 2 sine of pi. So I'm going to look back over here. Okay, we know sine is the y value, so it is 0. So I get y equals 2 times 0, so y equals 0. So this is an ordered pair of -2, 0. Now let's think about this for a moment. If we were plotting 2 pi, what that would tell me to do is to go to the right 2 and travel pi. Now it would make sense that this ordered pair would be like -2, 0 because I'm just moving to the left and I'm not moving up or down at all. Okay, so let's do this again. This time we're converting radical 3 pi over 6. So I'm going to do x equals r cosine theta. So the x value is going to equal radical 3 times the cosine of pi over 6. Now we may remember pi over 6 is like 30 degrees, and I know that the cosine of 30 degrees is radical 3 over 2. So when we multiply those together, I get x equals 3 over 2, because radical 3 times radical 3 is 3. And I know this is just like radical 3 over 1, so the denominator stays the same. Now to find our y value, okay, y is r sine theta. So I'm going to do y equals radical 3 times the sine of pi over 6. The sine of pi over 6 is 1/2. And once again, those are values we need to have memorized. You guys may have thought that that went away, but it hasn't. You guys need to spend some time reviewing that. So our ordered pair here is 3/2, radical 3 over 2. Now, this tells me that this ordered pair is in quadrant 1, and it would make sense that this is also in quadrant 1 because I'm moving to the right, and then I'm moving counterclockwise 30 degrees. So this does seem like a reasonable answer. So now we're doing the opposite thing where I'm going to convert the rectangular pairs into polar coordinates. So I'm going to start with finding the r value and do r squared equals x squared plus y squared. So r squared equals negative 1 squared plus 1 squared. So r squared is 2. So we get that r is the square root of 2. Now, the other thing that we need to think about is I need to look at this ordered pair right away and determine what quadrant do we think that's in. Okay, negative 1, 1 means I'm going to the left and up, so that would be in quadrant 2. So that's just kind of a good understanding for me to figure out where this angle and where the radius really should be. So now I'm going to find theta. So we know tan of theta equals y over x. So in this case, tan of theta is equal to 1 divided by negative 1. So that means that theta is equal to tan inverse of negative 1, which if we put that into our calculator, it gives us 45 degrees. Now, we need to think a little bit about this. Okay, so if I'm graphing this, we know that it should be in quadrant 2. So there's no way that this is 45 degrees, but what it does mean is that this little piece could be 45 degrees. So in order to determine what this angle actually is, I would need to do 180 minus 45, which is 135 degrees, or 3 pi over 4. Okay, so a lot of these basic trig skills are really coming into play. So our answer would be radical 2, 3 pi over 4. And that answer does make sense because that means we would go to the right and then travel 3 pi over 4. So let's do that again with this problem. This time, this ordered pair is in quadrant 1. Okay, so I'm going to say r squared equals x squared plus y squared. So r squared equals radical 3 squared plus radical 3 squared. So I have r squared equals 6. So r is radical 6. This time, when I do tan of theta equals y over x, I have tan of theta equals radical 3 over radical 3. So theta is equal to tan inverse of 1, which we know is 45 degrees. This time, it would make sense for this to be 45 degrees because, that's what I meant to do there, because this is in quadrant 1, so our ordered pair is going to be radical 6. I know 45 degrees is equivalent to pi over 4. So these problems definitely take a little bit of work, but we really just need to rely on what we have previously learned in terms of trigonometry. So now that we've seen how to convert ordered pairs, we're going to learn how to convert equations. So the things that we really need to think about when I'm changing from rectangular to polar, I want to eliminate x and y and replace them with r and theta. So once again, we need to remember that x is equal to r cosine theta. There we go, my pen doesn't want to work. Y equals r sine theta. R squared equals x squared plus y squared. And tan of theta equals y over x. This is stuff we definitely need to memorize. Yes, we need to memorize quite a bit this chapter, I know. Aren't you glad we split this up? So, this first one, y equals 10, I'm going to replace y with r sine theta. So I have r sine theta equals 10. we want to isolate r here, so I'm going to divide both sides by sine of theta. So I end up getting r equals 10. I know 1 over sine is the same thing as cosecant because we have previously learned that sine and cosecant are reciprocals of each other. So our answer here would be 10 cosecant theta. For our next one, we just need to replace the x. So I'm going to write r cosine theta equals 4. So I'm going to, this time, divide both sides by cosine theta, which gives me r equals 4. I know 1 over cosine is the same thing as secant theta. Trig never goes away, guys. Okay. Next one, x squared plus y squared. This one's a little bit different. So when I see this x squared plus y squared, automatically, this is the equation I think about. X squared plus y squared equals r squared. So we're going to go ahead and say r squared equals 16. Now we know our answer should be equal to r, so when I square root both sides, I get r equals 4. Now some of you guys might be wondering, why don't we do plus or minus? And the reason is, when we're dealing with just going out a radius of 4, we can't have a negative radius on this type of circle. So we just forego the plus or minus and just square root the number. Number 4, we have a few things. First of all, x squared plus y squared I know is r squared. Minus 2a, which is weird that we have a, but that's okay. I know that y is r sine theta. So if I look at this, okay, I can really factor an r out, and I'm left with r minus 2a sine theta equals 0. I can then go ahead and divide both sides by r, and this is provided that r cannot be equal to 0, just mathematically here. So I get r minus 2a sine of theta equals 0. So r is 2a sine theta. Okay, and our last one here, xy equals 6. So I have r cosine theta times r sine theta equals 6. So I get r squared sine cosine equals 6. I'm going to go ahead and divide both sides by sine cosine. So technically, and I'm going to move this over here, I get r squared equals 6 secant cosecant. Now, in order to go ahead and isolate r, I need to square root both sides, and I need to put a plus or minus out in front. So I get r equals plus or minus the square root of 6 secant theta cosecant theta. So on all these problems, okay, I'm really relying on these different equations to help us out. We know that I want my equation to end up being an r equals, I'm replacing my x's and y's with r's and thetas. Okay, so now what we're going to go ahead and do is take polar equations and change them into rectangular equations. So this time, we want to eliminate r and theta and replace them with x and y. So if we look at this first problem, what's kind of weird about it is that we just have r. And I know that often when we have r squared, that can help us out. So I'm going to start here by multiplying both sides by r. So I would get r squared, and this is a monomial, so this just becomes 4r cosine theta. Now, two really nice things happened here, because we know that r squared just becomes x squared plus y squared. And over here, r cosine theta we know is equal to x. So our answer here is x squared plus y squared equals 4x. Now, we don't need to complete the square or anything, but with our knowledge, we actually know this is a circle. So that tells us that this polar graph, which eventually we'll get to graphing, is an equation of a circle. Our second one here, theta equals pi over 3. Okay, this time I don't have an r, so I'm just thinking we need to somehow get rid of this theta. So the equation we learned that dealt with theta was that tan of theta equals y over x. So in this case, theta is pi over 3. So we need to think back and try and remember what is the tangent of pi over 3. And we know that that is radical 3. So I get radical 3 equals y over x. Now to make this equation look a little bit more normal, I'm going to multiply both sides by x, and I get radical 3 times x equals y. Now if we look at this equation, we know this is just a linear equation. So that tells us that this polar equation is just a line. Number 3, okay, we have r equals 4. So I know once again, with this r, I want it to try and be r squared. So this time, I'm thinking, why don't we just square both sides? Okay, the reason why I didn't do it here is because I had this whole expression going on, and it would kind of get messy with squaring every single thing here. It became easier to just multiply both sides by r to give us this r cosine theta. Okay, but in this case, I think it's easier if we square both sides. So I get r squared equals 16. Now we know r squared is equal to x squared plus y squared. So I get x squared plus y squared is equal to 16. So with these, what can make it tough is that there's not just a set thing to do. We really need to think individually about each particular problem and analyze what the best method of changing to the other variables actually is. Okay, so the final thing we're going to do, and sorry if you just heard Milo meow, he's mad at me because it's 10:30 and I'm paying attention to you guys on the video versus him. So, now we're actually going to go ahead and graph some polar functions. And I'm letting you guys know, next video, it's going to be kind of long because we're going to actually analyze how to graph every single type of polar equation, and we're going to learn some shortcuts. But today, we're acting like we've never graphed polar things before because we haven't. So just a flashback to Algebra 1 and even pre-algebra, before you learned how to graph functions in the rectangular coordinate system, we always made an XY chart. Okay, so we always just figured out, okay, if I can substitute stuff in and it gives me outputs, then I can just plot all those points and try and figure out what's going on. So, since we don't know how to graph functions in the polar coordinate system, we need to use an r theta chart. So our first equation is r equals 4 cosine 3 theta. So I have gone ahead and I've made an r theta chart for us. And the key to doing this is I need to do as much work as possible until we see a pattern. As soon as we see a pattern, it's totally fine for us to stop and do something different. Okay, so I'm going to go ahead and control the angles. So since this goes every 15 degrees, I'm going to work in terms of degrees. Now, if this is something that you guys want to put in your calculator, that's fine. Just remember, if I'm using degrees, my calculator should be in degrees. So the first one I'm doing, r equals 4 times cosine of 3 times 0 degrees. So I'm really doing 4 cosine of 0, which is 4. So plotting a point of 4 0 degrees means I'm going to the right 1, 2, 3, 4, and I'm not moving anywhere else. Now let's try 15 degrees. So I have r equals 4 times the cosine of 3 times 15 degrees. So that's r equals 4 cosine of 45. And when we put that in our calculator, we get something like 2.8. So that means I'm going out 2.8 and up 15 degrees. Let's try 30 degrees. R equals 4 cosine 3 times 30. Okay, 4 times the cosine of 90 gives me 0. So this gives me this point right here. So far, all I know is my graph is looking something like that. Okay, we don't know what's happening anywhere else. I'm just connecting these 3 points. I'm going to keep going and see if we continue to see any patterns here. So at 45 degrees, I would do R equals 4 times the cosine of 3 times 45. And when we put that in our calculator, we get negative 2.8. So that means I'm going out negative 2.8, and then I'm moving counterclockwise 45 degrees, which would put me right about here. When I put in 60 degrees, I get R equals 4 cosine of 3 times 60, which gives us negative 4. Negative 460 degrees takes me to right about there because I'm going to the left 1, 2, 3, 4, and I'm moving in a counterclockwise manner 60 degrees. If I put in 75 degrees, so R equals 4 times the cosine of 3 times 75 degrees, I end up getting negative 2.8, which takes me right about here. Now, I'm guessing that my next point is probably going to be at 0. Now, if I didn't know that, once again, I would put 90 in, and I end up getting 0. Next, if I put 105 in, and I'm not going to write all this stuff out, you guys can kind of see what we're doing there, but 105 gives me 2.8. Okay, so what that means for me, I'm going out 2.8, and I'm moving 105 degrees. So my guess, based on what I'm seeing here, is that my next point is going to be at 4, and then back at 2.8, and then back at 0, and then I'm guessing there's going to be one at that wasn't a great dot there, at 2.8, like right here, because that would kind of finish that pattern. This is actually what we call a rose. So I just want to show us, okay, most of these ordered pairs I got from actually plotting them. If we continued, we would just see that these points are overlapping. Now, if I was unsure, I need to keep substituting in points until we know exactly what's going on. Okay, and we're going to do one final one here. R equals negative 2 sine theta. So I'm going to start once again at 0 degrees. R equals negative 2 times the sine of 0 degrees, which is 0. So I'm going to start at 0. When I put 15 degrees in, R equals negative 2 times the sine of 15 degrees. And I get negative 0.52. Okay, so that means I'm going to go to the left negative 0.52 and 15 degrees, which would take me somewhere like there. Okay, if I put in 30 degrees, I'm going to do R equals negative 2 sine of 30, which gives me a value of negative 1. So negative 130 degrees would be about here. Okay, I'm actually going to zoom in just so it's a little bit easier for me to graph here because these points are all pretty small. There we go. At this point, I'm not really seeing what's happening, so I'm going to keep going. Okay, if I put in 45 degrees, R equals negative 2 times sine of 45 degrees, I get negative 1.41. Okay, so at 45 degrees, it would be like somewhere here. At 60 degrees, R equals negative 2 sine of 60. I get negative 1.73. Okay, so once again, that's taking me closer and closer to 2. Okay, let's try 75 degrees. 75 gives me negative 1.93. If I put in 90 degrees, I end up getting negative 2. Okay, now I'm going to try 105. And when I put 105 in, I get negative 1.93. So at this point, I'm noticing a pattern. Okay, I'm thinking negative 2 is as far as it goes, and I think all these values are going to mimic those values. So I'm thinking that this is going to give us a shape, something like this, which is a circle. Okay, and we will eventually learn that that actually is the equation of a circle. So at this point in time, and even on our test, if we forget how to graph a specific type of polar equation, we can always use an r theta chart to help us determine what this function looks like.